All right, so we've talked about ionic compounds, molecular compounds. Are just compounds composed of molecules, right? And a molecule is just a group of neutral atoms that are joined by a covalent bond. Okay, there are a few ways to represent molecular compounds. One of them is a formula, so a molecular formula. And a molecular formula shows it's different from the formula, a chemical formula for an ionic compound. It shows how many atoms of an element that a substance actually contains. Remember, with an ionic compound, we're looking at the lowest ratio. That's not true for molecular formulas, right? So we could have something like for butane. The molecular formula for butane is C4H10. Well, we can reduce this ratio, right? 4 is divisible by 2, as is 10. But with molecular formulas, we do not reduce, okay? So it's not necessarily the lowest whole number ratios like it is for ionic substances, or ionic compounds, excuse me. So that's one way we can represent molecular compounds. Another one is a structural formula. So let's take, let's take the formula, the molecular formula for ammonia. That's a molecular formula. We could also represent this in a structural formula, which is just kind of a very rudimentary drawing of what an ammonia molecule might look like. So this is structural formula. We can also do a ball and stick model, which in this case would be, here's our big fat nitrogen, and here's a little hydrogen, here's a little hydrogen, here's a little hydrogen. Let me put my H's in there, super tiny. There we go. Another way we can represent this is a space filling model, or 3D, or van der Waals. So we would have, once again, our big fat nitrogen. Maybe over here we have our hydrogen squooshed up. There's actually some overlap, which is why they look a little squooshed. And then there's another hydrogen. So they're not perfectly round in our space filling models, but they are nonetheless somewhat accurate in their depiction. So another, I'm going to erase this. Something else about molecular compounds that we need to discover. Some of their properties. And in general, we're going to compare them to ionic compounds. So they tend to have lower melting points than ionic compounds. And I'm going to abbreviate melting points, just MP, than ionic compounds, which I also abbreviate. That's CMPDS. They tend to be gases or liquids at room temperature. And molecular compounds form between nonmetals. And we will look at all of these things in a little more detail in class. And I will see you